Okay, we have this homework problem. This is actually problem number 2, which is like, basically the same as homework problem number 1. And in the homework, in each of the problems, we're only doing problems 1 through 9. Odd. Evaluate the limit or conclude that the function tends towards infinity, negative infinity, or positive infinity. Use the division of numerator and denominator by the highest exponent of x. Okay, well, the problem with infinite limits is that infinity is not a number. It just tends towards numbers that go on and on and on forever to infinity. So if we plugged in infinity into each one of each variable for x, you just get infinity over infinity. You don't get anything. So you have to try a different method. And so the method that we can do here is, all right, if we multiply 1, right, we get the same thing. Well, if we multiply 1 over x squared over 1 over x squared, that's the same term over itself is still 1 for every term except for 0 over 0. So, well, why would we use x squared? Well, we want to use the highest exponent that x has, and that's what we're going to multiply 1 over that. Well, why 1 over? Well, if we do that, then we can reduce the limit. We can reduce the terms. So this will be, and each time each step, you have to write this limit of x tends towards infinity. So now we're going to multiply this 1 over x in each term in the numerator and each term in the denominator. So we get 2x squared over, or 1 times 1 over x squared plus 3x over 1 times 1 over x squared plus 4 over 1 times 1 over x squared over, now we're going to do the denominator, 1 over x squared times 1 over x squared, or minus 2x over 1 times 1 over x squared plus 3 over 1 times 1 over x squared. Okay. So, I mean, you don't have, I'm just showing this, that what you have here now is the limit as x approaches infinity. You've got 2x squared over x squared. So this is 2x squared times 1 is 2x squared, and 1 times x squared is x squared, plus 3x over x squared plus 4 over x squared, and that's over x squared times 1 is x squared over x squared times 1 is x squared, and 1 times x squared is x squared, minus 2x over x squared plus 3 over x squared. Okay, now here we will we'll reduce, simplify. So the x squares over x squared, that's 1, they cancel. And so we get the limit as x approaches infinity, 2 plus, and then here the x we get 3 over x plus 4 over x squared. Over here, the x squares, they go to 1. Minus, and then here, the 2x and x squared, that's just 2 over x plus 3 over x squared. Well, why would we do that? Let's look off to the side. As fractions, as you increase the denominator, well, here you have 1 over 1, that's just 1. 1 over 2, that's a half. 1 over 3, that's a third. 1 over 4. So as the denominators get larger, the fraction gets smaller. So as you tend towards infinity, the numbers in the denominator get larger. As the numbers in the denominator get larger, like 1 over 100, 1 over 1,000, 1 over 1,000,000, and so on, the number gets smaller and smaller, the fraction gets smaller and smaller and smaller, and it tends towards 0. So what we do here is, all right, you can say limit as x tends to infinity for 2 plus, so now we're going to put the limit on each one of these. The limit is x tends towards infinity for 3 over x plus the limit as x tends towards infinity for 4 over x squared. And then now we're going to do the denominator. The limit as x tends towards infinity for 1 minus the limit as x tends towards infinity for 2 over x plus the limit as x tends towards infinity for 3 over x squared. Okay, so for this limit, since there's no variable, that's just 2. Here, and then once you apply the limit to that term, you don't write it anymore. So the limit to 3 over x, here 3 stays the same, but x gets larger and larger and larger and larger, and that goes to 0. So that's plus 0. And then here, that also is 0. So now the denominator, limit tends towards infinity for a constant, that's still just 1, minus the limit of 2 over x, the denominator gets larger and larger and larger, the fraction gets smaller and smaller and smaller, tends towards 0. And same thing for the third term, plus limit of 3 over x squared, that tends towards 0. So 2 plus 0 equals 2. 1 minus 0 plus 0, that's 1. So our limit is 2. So we've algebraically shown that and proved that the limit, it tends towards, for this particular function, tends towards 2. And you can check your work by looking at graphing it on the calculator. So if we put in the calculator, let's clear that. We start with original function of 2x squared plus 3x plus 4 close the parentheses divided by, open it, x squared minus 2x plus 3, and close that parentheses, and go to graph, and you can see that if we were to zoom that out some more, that the graph is going to go, maybe not quite that much. Bring it back in. We're going to see that eventually it's going to tend towards 2. So let's say we go to X max of 50. Let's see what happens there. 50. And it gets lower and lower and lower. Eventually it's going to get to 2. So if we increase the scale, the Y scale, and reduce that to, let's say, 5, and increase X max, let's go to 100. So here's 1, here's 2, and you can see that it's tending towards 2. So we've verified graphically that our answer is correct. And that's how you can check your work. And that's all we have. Please let me know if you have any questions, and have a wonderful day.